Now we're in the third diagram, and this is where things really open up. Here, we apply a much higher gate voltage. You can see it on the meter as VGS equals 5 volts. So what's the effect? That stronger electric field pulls in a lot more electrons. Instead of a thin, fragile path, that inversion layer becomes thicker, wider, and much more uniform, a solid conductive channel between the source and drain. Now we add another piece, a drain-to-source voltage, VDS. With the channel fully formed and low resistance, this voltage pushes a large amount of current through the device from drain to source. You can see that as the bold arrow, ID. So what's the result? The MOSFET is now fully on like a valve that's completely open. Current flows easily, and electrically, the device behaves like a low-resistance path, or what we call the ohmic, or linear region.
Now let's look at the final diagram. This is where things get really interesting. We're still keeping the valve wide open, with VGS at 5 volts, but now we dramatically increase the drain-to-source voltage, VDS. So what happens? That high positive voltage at the drain starts acting like a powerful suction force. It pulls hard on the electrons in the channel, so hard that it actually begins to reshape the channel itself. If you look closely at the right side, near the drain, you'll see the conductive path start to narrow. It tapers down and pinches off. Now, here's the surprising part. Even though there's this physical bottleneck, the current doesn't stop. Instead, it levels off. So rather than increasing indefinitely, the current ID reaches a maximum and stays constant. And that's what we call saturation. In this region, the MOSFET isn't acting like a simple resistor anymore. It behaves like a constant current source, regardless of further increases in VDS.
MOSFETs are basically voltage flexors. Off, on, or capped in saturation, letting current slide just right. Total power move for your circuits!
In other words, the MOSFET is a voltage-controlled switch, off, on, or saturated, letting current flow only when and how you want it.
Wow, Janice. I literally just explained that. Why are you echoing me?
Sorry, Gigi. I'll try using my own words next time.
See you next time.